please know that you have something and something to write on, because I'm going to be asking you to do some. Obviously, we've just checked to hear me, so that should be fine. If you are a bit or a bit loud, then just give me a shout in chat every now and again, and make sure that you can hear me okay. All right. Well, this is one of 3 sessions, and they'll be on Thursday, the next Thursdays after this one, all 6 p.m. to 7 p.m. And they're all on basic algebra. So today's workshop is on. Okay, so next week we're going to look at equations, and the week after we'll look at surds, indices, and logarithms. All these things until in all the rest of your engineering maths, as you know, as we've been going this year, these problems have come up as in your knowledge. So anyone who wants to attend and use them, that's fine. I think I'll make it open to everybody next time, so that anyone who wants to attend can do. I said that if you can't attend, please can you just go and watch the recording up to date. Whoever hasn't muted themselves, can you do that now, please? Thank you. Thanks a lot. Okay. I'm sorry, let me just go back to that page 1 second. I'm going to look today at collecting like terms, expanding brackets, factor, and algebraic fractions. Okay, so simple starts to algebra. Terms. No, it seems so I don't necessarily tell you anything. Is where when we say like terms, what we is terms that are separated by pluses and minuses here. Okay, so we consider this to be a term, for instance. If I see the variable x here, then every other term containing that variable is what we call a like term. So I've got 3 terms which are like terms. Notice that when and I'm going to cut them together, that's what it says. Notice that when I collect them together, I'm collecting also the sign before the term. Okay, so here has after it, but that plus does not belong to the term 3x. This 3x is a minus 3x. Remember, the sign immediately before the term belongs to that term. Okay, now I have a sign, and often this is the case. You can see this one doesn't have a sign, and this one doesn't either. By default, if there is a minus, it's a plus. Okay, I have to write plus x, because it's just like when we write 4, we don't have to write the plus 4, they're equal. So these terms here, I'm going to have x minus x plus 2x. Okay, terms here. So I'll have minus 5y plus 2y. Note that all I've done is rearrange the order that the terms came in. See that collecting x terms together would give me x minus 3x would be minus 2x plus 2 is 0. So the x terms have actually cancelled out. I have no x terms. In my y, collect them together. I've got minus y plus 2y. That's going to result in minus 3y, and that would be my final solution. I can't simplify anymore. So this is simplifying expressions. Okay. Just aside, why are these expressions and not equations? Because they're not equal to anything. So this is an expression, an algebraic expression where we've made it up with terms and subtracting from each other. Okay. Next one. Actually, I'm just there to stop and just go into chat and just ask everyone in chat, can let me know if you are seeing the.
Hey, Matt, yes, I can see all the annotations.
Oh, thank you very much, Matt.
No problem.
Okay. Okay, that means if one person can see them, I'm guessing everybody can. Right.
Would you call minus? Yeah. Why would that be full of a third?
Now, what you're doing is you're confused with an equation. I'm not asking to find the value of y. All I'm doing is collecting like terms to simplify the expression that was given to me. Collect these like terms. All I'm left with is minus 3y. Right. All right. The next one. So here I've got a terms, 7a. I have no other terms. So I can actually do that in my head, but I'll get out just for completeness. So 7a minus a. So I've got a minus 2b and a minus b. So minus 2 and plus 3c and a minus plus 3c. Okay, collect together all my a terms. So these are terms. 7 minus 10a is minus 3a. Minus 2b minus 2b will result with minus 4b. And finally, c minus 3c will just cancel out and give me 0. So that'll be my final result, 3a minus 4b. Let's move on to the last one. Now, different letters, but I've got an x squared. So the variable here is x, and my variable here is x, but my variable here is x as well. But that's not true. These are terms, x squared term, so collected together with other x squared terms. So reading across here, I've got one more x squared term here. So collections would be 12x squared minus x squared. Okay, 3x minus 10x. And then I've got minus, and notice that there's no variable there, but they're number terms. So they're also like terms. So minus plus 5. Okay. Squared terms then, 12x squared minus 11x, minus x squared plus is minus 7x, minus 4 plus 5 is plus 1. Okay, I can go further, so that's my function. Available for you as well, so don't worry about keeping up or anything. If I move on to the next page, I can check and see what I'm doing now is I'm going to do a 1 minute time in which to respond. Don't worry about it wrong, it doesn't matter. Okay? If you knew how to do this already and you were perfect at this, then you wouldn't need to be anyway. Really not a problem. So I'm timer, I'm going to ask you to do it. So you've got 1 minute to work it out. I'll just move this and vote A, B, C, or D. So in that, you just need to give me A, B, C, or D. Okay. So the question is 9x plus 4y minus z minus plus 8x. The answer is one of these 4 here. I'm going to click. Okay, I'll move on because I can see that everyone has chosen. Quickly check that. So 9x plus x is going to give 17x. 4y minus will give me minus, and z minus z will give me minus 3z. That's 17 minus y minus 3z. The answer is C. Well done, everybody managed to get that right. Well done. Okay, new skill, expanding brackets. We need to, by the way, if you have questions about any of, I don't think anyone will do because you've got that right, but any of the multiple questions that I ask you, you can question in chat and I can search for those at the end, or you can ask me the question at the end because I'll be here till 7 tonight answering questions. Okay, we're on expanding brackets now. So, okay, the bracket is another way in maths of saying that you want to multiply. Why written a bracket instead of writing multiply? Well, multiply 5 with 2, I can just write 5 times 2. If I want to multiply 5 with 2 plus 3, then it looks like this. Whether I want to add 3 to 10 or 5, sorry, 5, 5. So bracket, okay? So going back to here, I've got inside the bracket at least 2 terms, which is why the bracket exists. I have a bracket that to multiply with every term inside the bracket. 5 multiplying with 2x, well 5 times 2 is 10, so that must be 10x. And I've got 5 with 4y, so 20y. To this, I can't simplify, and so that must be my final answer. Note I expand and simplify, but simplify is a default. So where you can simplify, you should, and we'll see that in the next example now. Got a term which is 3, multiplying with both the terms inside the bracket. Sorry, excuse me. And another term outside the next bracket, which then has to multiply with both terms inside the bracket. So 3 times 2a is 6a. 3 is minus 3b. 3 is minus a. And 3 times 2b is minus 6b. It doesn't ask me to simplify up here. It doesn't say expand and simplify. For position that where you can simplify, you should. Collect like terms, like we did in the last slide. So 6a minus 30a is going to result of minus 24a. I've got 3b and minus 6b, and that will result in minus 9b, and that will be my final solution. This is similar, but 2 extra little steps in this. So I've got a term outside which is not just a number term. It has to multiply with everything inside the bracket, and so does this one, just like before. Well, 4 and x is x squared times 5y gives me 10xy. Now, if I in this expansion, I haven't had to worry about multiplying positives and negatives. I did have the negatives in the second example, but it didn't catch me too much. Now I'm a bit more careful because it's a very common error that's coming up that people will make. Remember, this 4y term is minus 4y. Multiplying it with this term, I've got a multiplying with a positive number, and so the rule, if you've forgotten, 2 multiplying together or negatives multiplying together will always apply with a negative, or a negative multiplied with a positive will give answer. So here number multiplied by a positive number, so I've got a negative answer. And the multiple 4 times y times x. Now I'm going to write 4xy. It was right, the number first, and then the letters in alphabetical order, although it makes absolutely no difference. You could y 4x, it would mean exactly the same thing. Okay, it just looks unusual if you mess about with the order. Usually number and letters in alphabetical order. Okay, minus 4y multiplying with minus 5y. This is minus times a minus. Lots of people would miss that. Okay, out for negative numbers. Minus is plus 4, and y is y squared. Okay, whenever I can. So there aren't any other x squared terms. 10xy minus 4xy. So that's going to give xy. So they're both y terms. They don't have the same variable, but they have the same group of variables, so they're like terms. And finally, only one y squared term, so that stays the same. Okay, so a question for you now. I'll just open to say. Okay.
Is sending this to everybody, or do you want it sent to you privately?
When I've done this before, it's more helpful if you send it to everybody because it helps people to make a decision if they're stuck between B and A or something. But if you send it to everybody, then don't. You know, it's absolutely fine.
I can send it to everyone. I just wondered if you wanted private or to everybody.
Anyone who's uncomfortable about sending it to everyone, that's absolutely fine. But if then that would be helpful to everyone else. Okay, question 5x open brackets x plus 4 minus 2 open bracket x minus 8. Remember what I said about negative numbers. Okay, I'll go and choose A, B, C, or D. Thank you for your so most people use the sleep. Correct. The solution is D. I'll just use 5 times x x squared. 4 is 20. Minus is minus 2x, and minus a is plus 16. To get the plus 16, which you must have done if you've got C, that's a very, very common error. Okay, that's plus 18 when I collect together the x's, plus 16. Okay, well done. Let's move. I'm going to expand again, but this time we don't just have a term outside of the bracket, we have 2 brackets, which means in effect I've got 2 terms outside of the bracket. So consider this as the bit, like I had last time. I could pretend that this 2 didn't exist, so I'll work that out in a minute. If that didn't exist, I'd say x times x and 4 would give me a result of x times x is x squared, and times 4 is plus 4x here. Okay, work that bit out. So does exist 2, so what now is I need to also multiply by the second term. So what I've then just got my two answers there from expanding now multiplied by the 2 times x is x and 2 is 8. Okay. Now everything is pluses, so we don't need to worry about our rules about plus. You know, when positive numbers multiply each other, but about some of the other questions down here. This one off, because we have 2x terms, then collecting those together would give me a solution of 6x. Okay, go at the next one. So 2x times 3, 2x times minus 2. Just finding, I own this term, first of all. That gives 3 is 6, and x times x is x squared. Multiplying with minus 2, so that's okay. Now I times by x, that's minus x, and then minus 3 multiplied with 2, so that will give me a plus 6. Collecting 2 x terms together here, that will give me minus 13x plus 6 as my final solution. Okay, one more here. 2 and x. I'll just first. So x is 14x squared. 2 is 5 is 10x. And I've got times 7x. So those 2 plus numbers, so it must be a plus answer. That's 2 plus the x. Plus 5 times minus 5. So plus, you can see, would give me a minus answer. That's minus 2. Collecting x terms together here in the middle, and 14x squared minus x plus 35 would give me plus 5x minus 5. I can't simplify. That's my final solution. Okay, you a question. So, in which answer and vote for A, B, C, or D. I'm going to timer now. That the correct answer. Several people in their chat, in the chat menu. Well done. Very quickly, an explanation. So x times x squared, x times minus 10x, x minus 4x, minus 10 plus 40. X term in the middle will just be simply x plus 40, which is, well done everybody. Okay, let's move to factorizing. Now, most people will, if they do stuck, will be stuck with factorizing. Start off a bit simpler, and factorizing is important because it helps you with algebraic as well. Without understanding factorizing, then you will algebra fractions, which are everywhere in engineering. When you're asked to factorize an expression, to do is I want you to see the expression as being of its factors. Okay, it means take a common factor and write the rest in a bracket. So back a few pages, it's going back to write. Okay, common factor. So having been given 10x plus 20y, you would factor. Common factor, you could have took 10 out of 4. It's a common factor. Okay, so this is the factorized version. It's not full, there's another 2 is common as well. Okay, so let's go back and have a look at our question. Imagine that 12xy, and if I do 12, the number 12 and the number 8 and the number 3, they're factors for 12, 8 and 3. So I need to split 12 down into 2 times 6 or 3 times 4 because none of them are going to be common. Okay, so the xy and c is just made up of 12 times x times y. The x squared y, I can split that times x times y. And so you just need to see it like this. And write it out if it helps. And this here would be minus 3 times y times y. When I've expanded it like this, I can now begin to see what are the common factors. There are no common factors in these numbers here, but there are factors in the variables. I have an x in each of these, and I each of these. xy is common to all of them. So taking xy as the common factor, being able to see it like this, I see that if I take out xy as a common factor, I'm left with 12. And let's just do this here. In the, if I take out xy as a common factor, I'm left with x. And if I take out xy as a common factor, I'm left with minus 3y squared. That is common to any of these. Moved the common factors. So we factorized expression now. Okay. Slightly different. So when you're factorizing a quadratic like this, we have a quadratic term, an x, a quadratic meaning power x to the power 2, and we have an m and a number term. We know that it ties into 2 brackets. We know to multiply 2 brackets, we just did that. We have to have an x times an x to give us this x squared here. The numbers here have to multiply to make 6. So I need out what numbers do I need to write in here that I put together to make 6. I'm looking for factor pairs of 6. So 1, 6 is a factor pair of 6 because that does make 6. Okay, so 2 and 3. Now I need to consider which of these factor pairs when I also make 5. Now, one could make 5 if 6 and a minus this one, but make plus 6. So therefore, that cannot be the factor pair I need. So I'm either going to have 2 plus numbers, or 2 positive numbers, or 2 negative numbers. And then this positive 2 and a positive 3, put those together, I get 5. And when I time together, I get 6. I'm looking for. When I together, I get 6. When I add them together, I get 5. And that's long-winded, but actually mentally, because the numbers are usually quite simple, you quickly can say these must be 2 and 3. Now, note that I've written them in makes no difference whatsoever. They still make 6, and they're still going to make 5 when you add them together. So it's plus 3. And then these are all pluses, so therefore these are pluses as well. In the negatives, so we have to do a bit more appropriately with our numbers. Quadratic, so we know that it would factor we want to make x squared, we have to have an x here, so that x times x gives us the x squared. Now I'm looking to make the number minus. Let me just call. So two pairs of 10 would be 1 and 10, or 5. One of these numbers has got to be a minus. So minus 1 times 10, that would make 10, that minus 10. Or 1 times 10, that would make minus 10. So it's 1 is plus and 1 is a minus. One of these numbers will also make, when I add them together, will make minus 3. And I can't make the figure of 1 and 10. It must be made out of 5 and 2. And if I be minus 3, I'm going to have more negative and less positive. So 5 plus 2. And that I've got times by minus 5, minus 10. That's what I wanted. And I've got added to minus 5. That's just minus 3. Wanted. So those numbers are correct. So it's x plus 2 and 5. All right, let me ask you a question now. Okay. In which and put vote in your chat, please. Okay. So I'm considering pairs of 15. I've got to make a plus 2. I can see that that's going to be plus 5 and minus 3. So that's 5, x 3. Okay. Need to write this out. You can do that mentally, but by all means do if it helps. Okay. It really doesn't matter whether you do or you don't. Why doesn't it matter what these are written in equal? You can very formal there. I was just going to say it's a product, and the order that you time things in doesn't matter, but Matt has looked me there and told me that multiplication is commutative. Thank you. Okay, so it's just like having two numbers, times 2 times 3, sorry, 2 times 2 is the same as 3 times 2. It doesn't matter which order you multiply these in, okay? All right. So I was talking able to see terms as factors and important and algebraic fractions. When you have to simplify, what they mean is right. Okay. We cancel common factors. Okay, so it is going to simplify this into something simple. Okay, we need to do. So I need to think of this denominator in expanded form as its factors. Be that this would be 5 times x times y times y. Those are the factors making up this expression. And I can see that in the denominator, I've got 5 times x times y. And common factors. So 5 in the numerator with a 5 in the denominator. Got an x here, a here, and a y here. So with, and I'm like, I've got a 2 instead times 5. Mistake. Okay, numerator, I'm left with y. I'm left with x. I had 5x over x squared. Well, what would have 2? That y would have, and this would have cancelled out with one of the x's there. I can see that next what I'm left with in the numerator there. Anyone tell me? What am I left with? Yeah, John, and he's because what you're doing is you're saying, well, it's 0. That was my point. But if you put everything out on the numerator, you're still left with a 1. Okay? Because 1 is everything. So you could actually say 1 times all of that, and 1 left over. So when you put everything out, please remember it's not a 0. So 27 I'm going to see as 9 times 3. A is A. B squared is B times B. 5, 1, 2, 3, 4, 5. 9. A. 1, 3, 4, 5, and a C. So simpling out common factors. 1, 2, and I've got 1, which will cancel with 2 B's here. I've got C here. In my new problem, I'm left with 3, A, C to the 4. A to the 4. I'm left with B. Okay. To write this expanded way, this explanation of what's happening. It's a bit messy. I'll show you, and you can kind of be careful because it gets a bit messy. So 9 into 9 go 1, so that's just a 1. 9 to 3. A cancels that, so I'm just going to be left with an A. Making all these words will cancel with 2 of them from there, so I'm going to end up with a 3. C from here, so I'm left with a 4. I see A, C to the 4, which is what I had here. The denominator, but it looks quite messy. So just careful when you're doing that, because there's lots of small numbers everywhere. Okay, full to check when doing so. I'm going to simplify. So if I'm told that I have to simplify this fraction, know that I'm going to have to factorize this if I equation. Okay, the I've got down here is x plus 1. I allow x with an x up here. Okay, so see that the could be factorized into x plus 2 and an x plus 1 in the numerator, the denominator, and so it simplifies into x plus 2. The way to take either in the numerator or the denominator, if you simplify, then what you've got to do is factorize. Okay, or simplifying by common factor of a bracket rather than a term. Okay. All right. So what A, B, C, or D? Simplify this fraction. Okay. Most people there I could see were telling me that they thought the answer was D, and they were right, that is D. That's good to shout rather than writing it out in full. 6 from here, so I'll be left with a 1 there. So 6 is go to 2. Okay, I'm still with 1 of the x's here, so I'm still going to have 2 of them left over. 2 y's from here, we'll cut 2 of them from here, so I'm still left with 2. 2 z's will cancel with 2 from here, so I'll be left with 2 in the numerator. So this 2 is my number 2 term. It is x squared in the numerator, and if y terms left, my z will be z in the denominator. I have no x terms, no z terms, y squared. So was t. Okay. What that you have to often do with algebra as a single fraction. Okay. So let's just think about numbers. If I had 2/3 added to 1/5, what I find a common factor. So I can see a factor of 3 and 5 would be, common multiple factor. Common multiple of 3 and 5 would be 15. Now, in the 3 into a 15, I divide it by 5, and so I'd have to multiply the top by 5 as well. Okay, so 3 to make 15 in the denominator, 2 times 5 to 10 in the denominator. 15, so that must have multiplied by 3. The numerator must also multiply by 3, so that makes 3 in the numerator 13. Now, it's the same logic applies to fractions because they just stand for numbers. Okay. So it will be, common multiple for 7 and 3 would be 21. So I'm going to write my common multiple here. 1, this has had to multiply by 3, so therefore this will also multiply by 3. So 5 is 15x has had to multiply, and so it's in the numerator. That means I'm not 2x anymore, but a 40. Okay, 15x plus 14x over 21. So that is now x over 21. It doesn't add to. Okay. A common factor this time would be 6. Okay, they're both common. Sorry, I keep calling it a factor. Common 2 and 3 would be 6. So you might 30 make your calculations much harder because your numbers are bigger. So that multiple is always a good idea. What did I vary by to make 6? So I multiplied it by 2. So therefore I must top by 2. Now if I'm making a whole term, not just one term, by 2, that's when I need to write a bracket. So I'm writing it like this. 2 had to be multiplied by 6, so therefore this whole must also be multiplied by 3. But I must replicate that minus here, so it's minus 3 times whatever that term was. The things that we learned there, so 2 times 2x and 2 times 2. So that's plus 4 minus 3 times minus 1, so minus 15x plus 3, or okay, and 4x, collecting like terms now, so 14x is minus 11x, and plus 3 is plus 7, and that's all over 6, and that's my. Now this time we've got not in the denominator but terms, so we've got variables introduced here. So be 20x. I don't need to do x squared. I could. 20x is 20 is also a common multiple of these two denominators, but is a simpler multiple, because I can make 5 into 20x by just times by 4. 4 as well. Just change the numerator well in the same way. So 4 is that numerator. So there must be a minus here as well. By 5 to make that new denominator top by as well. So that's 5x plus 5. Multiply, just like we learned in the brackets. So 4 times x, 12x. 4 times minus 4, minus x, minus 10x, minus times plus 5, minus 25, or 20x. Okay, collecting terms, as we learned earlier. 12 minus 10x is 2x, and minus 25 is minus 29. Okay, so let's see. Just pen into a pointer. And got a minute, so you'll have to be fast. I'll read it out to give you some extra time. We've got writing the same fraction, x plus 2 or 5 minus 2x plus 3 all over 3. Okay, off you go. You. Yeah, Matt. Answer, which is really good because this pattern involves all of the skills that we've learned earlier. So 5 and 3 would have a common factor. Means it's been multiplied by 3, so therefore the numerator gets multiplied by 3. It's in the middle. 3 has to be multiplied by the numerator gets multiplied by 5 as well. X plus 6 minus 10x minus 15. In like terms, 3x minus 10x is minus 7x. 6, 15 is minus 9. That's all over. That's minus 9 all over 15. That's answer B. Okay. I'm just going to move to the last page. Now, what I'm going to do is just read the slide, then I'm going to work top with you so that I chat in a bigger window, and then you can use questions until 7 p.m. Or even later if you need to ask more questions, that's fine. If you want to talk to me and ask using the talk feature, then mute yourself and you can ask questions that way as well. If you need to go back to a particular slide and I'll show you something in particular, and if I'm quite, because most of the solutions that were given to that were correcting that this is something that's fundamental and easy for you, and that this basis for you to work on. Next week, though, we'll be looking at equations, and we're looking particularly at solving linear equations, that's the simple form, and also quadratic equations. So if you wanted to attend that, then that would be next Thursday, same time, 6 or 7. Send an email to everybody on the course, and anybody who wants to attend can do. Recording will be made available to you. Go link, and I can send you that. So go through this at your own pace if you need to at any time in the future. Okay, I'm going to stop. So let's just see.